Light can make matter move without touch. Structure can make light disappear without absorption. Some energies are allowed to persist, others fail to complete a path. These outcomes do not come from exotic chemistry or hidden intelligence. They come from constraints. In every system you are about to see, energy is free to enter, but what happens next is not negotiated. It is selected by structure. Once constraints are fixed, behavior stops being flexible and only one outcome remains possible. This material moves because staying still is no longer allowed. Light doesn't push it, geometry just removes the option to remain unchanged. Nothing touches this material, nothing pulls on it, nothing applies pressure. Yet when light strikes its surface, the shape begins to change. Switch the light off and the motion stops. Restore the illumination and the same deformation returns precisely and repeatably. We normally associate motion with force. Push something and it moves, remove the force and it settles. That framework fails here. Light arrives carrying energy in discrete units called photons. The energy carried by each photon depends on the wavelength of the light. When the photons are absorbed, their energy enters the electronic structure of the material. At first, nothing visible happens. The energy is stored internally rather than released as heat. The decisive factor here is construction. Light-activated materials contain molecular units that alter their configuration when electronic energy changes. Each individual change is microscopic, far too small to observe. But these molecules are not free to move arbitrarily. They're locked into a solid framework, typically a polymer network that restricts motion differently along different directions. This directional dependence, called anisotropy, directs how light behaves. As illumination continues, many molecules attempt to reconfigure simultaneously. Internal stress accumulates. Because motion is blocked in most directions and permitted in only a few, that stress cannot relax evenly. It is forced to resolve along specific geometric paths. That resolution appears as mechanical strain. Now, strain here does not require an external push. It appears whenever a structure is displaced from its lowest energy configuration without freedom to reorganize. At this point, the flat shape becomes energetically inaccessible. Remaining unchanged now requires more internal energy than bending. So the material bends, not because light applies force, but because stillness is no longer permitted. This is not simple heating. If temperature alone was responsible, energy would spread uniformly and deformation would be inconsistent and directionless. Instead, curvature follows the spatial pattern of illumination. Change the direction of light and the deformation rotates with it. These materials appear in soft robotic actuators, adaptive optics, and self-deploying surfaces. They operate without motors because anisotropic constraints decide how energy can resolve. Here, energy enters but the option to remain unchanged disappears and hence motion follows. Under these constraints, the shape change is unavoidable. Once alternatives are removed, the outcome is forced. So far, energy entered matter and forced matter to change. In that case, geometry decided how energy could be released. Now we move to systems where geometry does something more severe. Instead of guiding energy after it arrives, structure determines which energy is allowed to exist at all. Matter will no longer respond to light. Light will be filtered by space itself. Inside this structure, some wavelengths cannot exist, not because they are absorbed, but because geometry prevents them from forming a stable wave. Light enters this material, but not all of it survives. Some wavelengths pass through cleanly, others fail to appear beyond the structure. They are not absorbed or reflected, they simply cannot propagate. This has nothing to do with chemistry. Photonic crystals are defined by periodic geometry, a pattern that repeats at a spacing compared to the wavelength of light. Light also behaves as a wave, and waves can propagate only if they maintain a stable phase relationship as they move, meaning whether the wave's peaks and troughs arrive in sync or out of sync. Inside a repeating structure, light encounters boundary after boundary at regular intervals. Each boundary partially reflects and partially transmits the wave. Individually, these interactions are weak. Together, they dominate. For some wavelengths, reflected components remain in phase with the incoming wave. The pattern reinforces itself and propagation continues, while for other wavelengths, the reflection arrives out of phase. Interference accumulates, and a stable wave pattern cannot form. This produces a photonic band gap, a range of wavelengths that cannot exist inside the structure under these conditions. Those wavelengths are not destroyed, they are just excluded. If a wave cannot maintain coherence across repetition, propagation collapses. There is no viable path forward. Change the spacing of the structure and the allowed wavelengths shift. Change the angle of entry and the response changes again. The material is not reacting here, it is enforcing constraints. This is why photonic crystals can guide light without absorbing it. They do not trap energy, they restrict motion. You see this principle in structured optical fibers, iridescent biological surfaces, reflective coatings, and photonic chips. However, there are limits. Disorder breaks the effect. Incorrect scaling eliminates the band gap. And therefore, photonic behavior exists only while repetition holds. Here, geometry fixes the condition and light obeys. Wavelengths that fit persist, and those that do not cannot. This behavior isn't engineered, it is selected. Photonic crystals show us how geometry can forbid propagation, but there is a deeper restriction possible. Instead of preventing certain wavelengths from existing, structure can allow light to enter and then remove every viable route for it to leave. In the next system, light is not filtered, it's exhausted. This surface isn't black because it absorbs light. It is black because geometry removes every efficient path back out. The surface appears flat, light strikes it and almost nothing returns. No glare, no highlight, no reflection. Ultra-black behavior is not pigment-based, it is geometric. The surface is filled with deep, narrow structures arranged densely and vertically. It may be in the form of cones, pores, tubes, or cavities. The exact form varies, the effect does not. When light enters, it does not encounter a single surface, it enters a maze. Each interaction absorbs part of the photon's energy. Remainder is redirected deeper into the structure. Reflection does not send light outward, it sends it inward. The geometry is anisotropic, meaning the geometry behaves differently depending on direction. Entry is easy, but exit is not. With each interaction, the probability of absorption increases, not because the material is unusually absorptive, but because the photon is forced to interact repeatedly. Eventually, absorption becomes inevitable. Nothing captures the photon. Every efficient escape route has been removed. That is why darkness is angle independent, as light arriving from the side still enters the same maze. These materials are used in telescope baffles, infrared detectors, and calibration targets, not to hide light, but to eliminate measurement error. If you damage the structure, reflectivity rises immediately. Fill the cavities and absorption collapses. Ultra-black behavior exists only while geometry denies exit. Photons enter, escape paths disappear. Energy resolves as absorption. Darkness is not applied here, it is enforced. So, when geometry dominates, freedom disappears. So far, geometry has forced matter to move, forbidden certain waves, and removed all exits for light. Now we move on to systems where geometry does something subtler. Energy is not absorbed, it is not excluded. Instead, structure decides where energy is allowed to go. Waves don't choose their direction here. Repetition removes most paths before the waves even arrive. This material bends waves in directions they should not follow. Energy enters in curves inward instead of spreading outward. Signals arrive earlier than expected. Paths appear that should not exist. Nothing about the chemistry explains this. Metamaterials derive their behavior from arrangement, not composition. They are built from repeating structural units. Meta-atoms larger than molecules but smaller than the wavelength effect. At that scale, waves no longer experience smooth material, they experience structure. Each unit slightly delays, bends, or shifts the phase of the wave. One interaction is insignificant, thousands are decisive. Repetition removes degrees of freedom here. Instead of spreading naturally, the wave is forced to conform to the geometry. Paths narrow, alternatives disappear. This is how effects like negative refraction arise. Not because the energy flows backward, but because phase evolution is fixed by structure. Change the spacing and behavior shifts. Rotate the pattern and the response rotates with it. The chemistry remains unchanged. The same logic applies to light, sound, and mechanical waves. Different carriers, identical constraint mechanics. Metamaterial behavior exists only within a defined wavelength range. Disorder breaks it. Once repetition fails, freedom returns. The structure does not control the wave, it removes the options before the wave arrives. Once those options are gone, the outcome is forced, and here the structure doesn't decide, it eliminates options. Across all four systems, nothing extraordinary is occurring. Light carries energy, waves propagate, and matter responds. What changes is not the laws of physics, it is the number of options permitted. Light-activated materials move because stillness becomes inaccessible. Photonic crystals exclude wavelengths because coherence cannot be maintained. Ultra-black surfaces absorb because escape routes disappear. And metamaterials redirect waves because free propagation is removed. No sensors act, no controllers intervene, nothing decides. Outcomes are not chosen, they are selected. So when constraints dominate, behavior becomes inevitable. And once geometry removes every alternative, no other outcome is possible.